slope, the basics. The slope of a line is rise over run, or the change in y over the change in x. So m is we typically use m for slope. So that's the rise over run, or we could say the change in y over the change in x. Another way to write that is to use this Greek letter delta here, okay? Delta y over delta x, and delta is read change in, okay? So if you see delta in math or science, it typically means there's some sort of change there, change in, all right? So if you're given 2 points on a line, x1, y1, and x2, y2, all right? If you have a line, it can be any 2 points on that line, all right? Then the slope, m, equals y2 minus y1 over x2 minus x1. So again, changing y over changing x. But notice, I have the purple here together, and here's the purple together. Here's the green and the green are together. So my point is, I have my points, green and purple, just to denote them differently. Whichever point, if I, x2, y2, I have it first here. The purples, you can't have purple, green, green, purple is what I'm saying. Okay? Purple comes first both times. Or green could come first both times, okay? So y1 minus y2, over x1 minus x2. So it doesn't matter if you start with y2, then you must start with x2. And also if you start with y1, you must start with what? X1. It doesn't matter which one you start with, because I could call my x1 y1, and you could call the same point x2 y2. Could happen. Okay, so, but don't mix it up and do y2 minus y1 over x1 minus x2. You can't start, if you start with y2, you got to start with x2. You start with y1, you got to start with x1. Okay, so let's look at some examples of slope here. So let's find the slope and state whether the line rises, falls, is horizontal or vertical. So remember, slope is rise over run. So let's talk about the rising and falling part real quick before we actually start finding these. If you have a positive slope, what is your line doing from left to right? It's rising. What if you have a negative slope? What's your line doing from left to right? It is falling. If your line is horizontal, right, horizontal side to side, is there any rise to that? No. So it's 0 over something, which is 0. So 0 slope is horizontal, and then vertical line, that's a bunch of rise over no run. That's called undefined slope. Okay. This slope is not defined, so we call it undefined. All right? And we know from horizontal and vertical lines, right? Horizontal line has 0 slope, and there's y equals a number. Vux, vertical line, undefined slope, and x equals a number. So we know those things. They're all intertwined here and interlinked together with lines and linear functions and linear equations and that kind of stuff. So here, -1, 3, and 2, 4. Find the slope. And then after we find it, if it's a positive slope, we're going to say, hey, the line rises. If it's a negative slope, hey, the line falls. If it's a 0 slope, or the slope is 0, we're going to say, hey, it's horizontal. And if it's undefined slope, we're going to say, hey, it's vertical. Right? So here, I'm going to call this x1, y1, and x2, y2. But there's nothing that says you can't do this. You couldn't call this, you could do this here. Doesn't matter. Just don't call it x1, x2, or y1, y2, or something like that, right? X first, y second in each one. And then the subscripts are like a name. You know, this first point has a name of 1, the second point name of 2. You could call it x sub a, y sub a, and x sub b, y sub b. I mean, it's not 1 and 2 is not magical here, right? So you're just kind of denoting it, giving it a name here. So every time I work something in math that requires me to remember something like a formula like this, I don't like formulas in the sense of special types of formulas, but sometimes you can't get around them. Like, you have to know the slope formula to find the slope. You got to know what's going on, or you can't do it. So every time I work a problem, every time, you're going to see it on this, every time I work one on this video, y2 minus y1. Every time I work one in class, I write the formula down. Okay? Every time I'm helping a student with this, I write the formula down, because I want to model for the student. I want to model for you what you should do. You should write it down every time, because then when it comes to the test, if you've been practicing, because you need to practice, and you write the equation down every time you do it, you may still need to write the equations down for 5 minutes a day. That's not much time, y'all, up until you take your test. and then you won't forget it. You know, I forgot, whatever. You should have written it down more times, okay? So do more work, all right? If what you're doing is not working, do more work. Figure out something that does work. So M equals, all right? So here Y2 is 4 minus Y1 is 3, right? So 4 and 3. And then over X2, if I start with Y2, 4, I got to start with the point that goes to it. So that's got to be 4 and 2 here, right? So it's going to be 2 minus, and X1 is a negative 1. I'm going to show that this time. I'm going to show minus a negative 1. But this guy on this video, think that 2 signs in a row is way more complicated than 1 sign. I will never say to you, hey, put plus a plus or plus a minus or minus a plus or minus a minus. No, that is silly. Okay? Now, if your teacher wants you to do that, you do what they want you to do. I won't understand why they do that, but you go right ahead because that's what they want you to do. All right? I personally think it's more confusing. You learn the rules. If the signs are the same, add. If they're different, subtract. Keep the sign a larger number. You get 1 sign between each number, and you go with it. Okay? So here, 2 minus a negative 1. So this is, I can go ahead and 4 minus, I'm just going to leave it for now, over 2. And what kind of 1 do I now have? A minus, a negative is positive. So now I have 1 sign for each number. The 4 is positive, the 3 is negative, the 2 is positive, the 1 is positive. Okay? You always want 1 sign for each one. So this is going to be 1 over 3. Can I simplify that? Meaning, is there any common factor I can divide out or anything like that? And the answer here is no. So my slope for this one, M equals 1/3, and that's the first part of the answer. And this line rises. Why does it rise? Because the slope is positive, and it rises from left to right. Now, because 1/3 is really close to 0, it's not going to, it's going to rise slowly. It's not going to be a steep line like that, okay? It's going to rise slowly. All right, so what about the next one? 4, -1, and 3, -1. So we have, I'm going to label this X1, Y1, X2, Y2. And again, how you label this doesn't matter, okay? Which one you call X1, X2, and all that other stuff, I'm going to fix this because I don't like the way it looks. Which one you call X1, X2, or X1, Y1, I'm sorry. I just said it backwards. I said don't do that earlier. X1, Y1, and X2, Y2. It doesn't matter which one you call which, okay? Because remember the formula can be one way or the other. But what matters is you get X first, Y second, and if you start with X2, you start with Y2, start with X2, and vice versa. So again, guess what I'm going to do? M equals. I'm not going to try to plug it in right here. Don't start telling me numbers 4 and 3 and -1. No. Y2 minus Y1, X2 minus X1. And here's the other thing. When you do this, like notice I'm going to put Y2 first every time. That doesn't mean it's a better formula. That's just the way I choose to remember it. Okay? That's just the one I choose to commit to memory. The other thing is I'm always going to call the point that's first, or if they're stacked on top of each other, the one up top, X1, Y1. Again, that's just what I do. That's the consistency I do when I work problems. If you were watching me work one of these in my office and nobody was around and I was just working a slope problem for fun, I would call the first or the top point X1, Y1, and then I would always put my formula Y2 minus Y1 over X2 minus X1. Always. So, but it can be the other way. And sometimes when I present it, I'll mix it up just to be different, but here I'm probably not going to. We'll keep it this way. All right. So M equals Y2 minus Y1 over X2 minus X1. I write my formula down so I don't ever forget it. And then especially for the test, because that's why I'm in the class to try to succeed. So then Y2 is -1. Then I have minus Y1, which is minus a -1. So I'm going to put my minus, but minus a -1 means plus 1. So I'm only going to show this one time. Down here, I'm going to go ahead and say, hey, I know that minus a negative is a plus. That is something you can do in your head. A negative in a formula just means change the sign. A negative in a formula just means change the sign. So up here, my 3 was positive, but when it came over here, it's negative because that negative's in the formula, right? So then here, this -1 becomes what? Positive because the negative's in the formula. A negative in a formula just means change the sign, okay? And then over, if I start with, really you don't know which negative one you started with, but I started with this one here, so let's start with the 3, okay? So then we say 3 minus 4, and that's going to be 0, right? Negative 1 plus 1, 0. Over 3 minus 4 is negative 1. So then my slope, what does 0 over negative 1 become? 0. My slope is 0. And remember, Vux and Hoy. Hoy says horizontal line has 0 slope. So this line here is horizontal. And think about rise over run. If it's 0, it has no rise over a bunch of run. It has a bunch of side to side, but no up and down. All right. So let's move on. Let's go to the next one. And guess what I'm going to do first? M equals y2 minus y1 over x2 minus x1. And it took my y part away, so try to fix it here. I'm going to call this x1, y1, x2, y2. My slope is negative 2 is y2 minus a negative 4 is plus 4 over x2 is 4 minus 6, and negative 2 plus 4 is 2. 4 minus 6 is negative 2. Is that right? So that's what? Negative 1. So my slope is negative 1. So we saw one earlier that was a fraction that didn't simplify. Here's a fraction, and it does simplify to a whole number. Sometimes they can simplify just to another fraction. So all those things that you know about simplifying fractions and everything else, that still comes into play with this, right? You don't forget something in math because you're not using it anymore. It all builds. You learn something, it could pop up at any time in the future with something else. So this line falls. Why does it fall? Not because it became a 1 or negative. It's because it's negative. It's the negative. Doesn't matter what's after the negative sign. Negative. It falls. All right, so let's keep working these. I'm going to call this x1, y1, x2, y2, and m equals, and I don't care if my formula is already on here. I'm going to write it down again because this is preparation for something. I am preparing for the test. And if I need to know this for the test, then I need to prepare in such a manner that I will be successful. And that philosophy that I just said to you works. My son had baseball practice yesterday. Tryouts for his school team. He needed to be prepared, right? Prepare the same way each time, so that way when he goes to something like that, he's prepared, okay? If I have a job and I have something to do, I still prepare for success. Whatever it is, prepare for success, all right? So then you won't always get success, but prepare for it. And then understand how to handle failure. There's your extra life lesson in the middle of this, all right? So m equals what? Well, y2 is 5, and then minus negative 4 is plus 4, and then over 3 minus 3. And that's going to be 9 over 0. And 9 over 0, that is undefined. And you don't have to spell it out for me. If your teacher wants you to write it all out, that's fine. Okay, and I don't mean the German word und, which means and, but here undefined. So the slope is undefined. And then if it's an undefined slope, that's Vux. Vertical line, undefined slope, x equals a number. So this is a vertical line. Vertical line. So let's look at some more of these. And let me erase this that I had to put here. Negative 7, negative 3, and negative 7, negative 14. Got negatives all around here. All right, so let's look at this one again. I'm going to call this x1, y1, and x2, y2. And then I'm going to write my formula down so I can be prepared for success on my test. I may not be successful, but that just means I got to come back stronger the next time. All right. So y2 minus y1, x2 minus x1. And then, so my slope is y2, which is negative 14, minus a negative 3 is plus 3, over negative 7 minus a negative 7 is plus 7. And that's going to be negative 11 over 0. What? Again? So that's what? Undefined. That is undefined. That's not really a D, so let's make that a D. It's undefined slope, which we just said is a vertical line, right? Remember VUX. Vertical line has undefined slope and is x equals a number, the formula for it, the equation. I shouldn't say formula. The equation of the line would be x equals some number. In this case, it's x equals negative 7, by the way, because that's what my x values are. So the next one, negative 5, 12, and negative 1, 2. This is x1, y1, x2, y2. And guess what I'm going to do? Yep, you guessed it. I already told you I was going to do it. If you don't know now, you haven't been listening. y2 minus y1 over x2 minus x1. So 2 is my y2, so m equals 2 minus 12. This is my y2 minus y1. I think I said that wrong. y2 is 2 minus y1 is 12. And then if I start with 2, I got to start with the x value that goes with it, negative 1. Okay? So negative 1 minus a negative 5 is plus 5. Minus a negative 5 is plus 5. All right? So that's going to give me negative 10 over 4. Can I simplify negative 10 over 4? Yes. 4 doesn't go into 10, but what goes into both of those? 2. Right? And then when we have a fraction that's negative, we typically just bring the negative out front. So 2 goes into 10 5 times and 4 twice. So then my slope is negative 5 halves. And what does this do? It falls. It falls. So what about the next one? 7, negative 1, and 3, 12. So this is x1, y1, x2, y2, and m equals y2 minus y1 over x2 minus x1. See, if you just practice a few times and write this formula down over and over and over again each time you do a problem, even if there's 2 or 3 or 5 or 10 or 12 problems on the same page as you're working, you'll be prepared. Always, always, always try to be prepared. Am I perfect? Am I always prepared? No. Do I try to be? Yeah, but I'm human. I make mistakes, right? So, but again, how do we come back from those? Be prepared next time, right? So here, m equals, well, 12, and then minus a negative 1 is plus 1, over 3, nope, negative 3, minus 7. So this is going to be 13 over negative 10. Can I simplify that any? No. So again, we're going to bring that negative out front. Negative 13 tenths. And the slope is negative, so what is it doing? It's falls, okay? So the first 4 I gave you 1 rises, 1 falls, 1 horizontal, 1 vertical, and after that all bets are off. Okay? So let's look at the next one. 2, 0, and 5, 0. This is x1, y1, x2, y2. And m equals y2 minus y1 over x2 minus x1. M equals y2 is 0 minus y1 is 0 over x2 is 5 minus 2 is x1. So this is going to be 0 over 3, and 0 over any other number is 0. What I mean is you can't have 0 over 0 is not 0. That's something that's special that you won't even see in algebra. Not that you can't do something about. So m equals 0. So this is horizontal HOI. Horizontal line has 0 slope. The O in HOI is actually the number 0. So, and it's y equals a number. So that line would be y equals 0 actually, because that's your y values in your 2 points. All right, so see what we have next here. Oh dear. 1/2, 3/4, and -5/2, 2/3. Are you kidding me? No, I'm not kidding you. Okay? Software packages, books, teachers love this kind of stuff. Okay? I personally think I can decide whether or not you know the slope formula by giving you just whole numbers or integers or whatever. But this could happen. So we need to be prepared, right? And look, you should already know how to do fractions. When you add or subtract fractions, you need a what? A common denominator. So let's go through and label this and do our formula and all those things. So this is x1, y1, x2, y2, and then the slope is y2 minus y1 over x2 minus x1. All right, so I'm just going to swap some colors here for fun. Actually, you know what? I'm going to wait to do that. So the slope then is going to be, we'll do it this way. In the numerator, we have y2 is 2/3 minus 3/4. Okay, so we'll do that in purple, and this next one we'll do in blue. So so y2 minus y1, and then x2 is -5/2 minus 1/2. -5/2 minus 1/2. So right now we still have the slope equals something here, okay? Now, if I look at the numerator, 2/3 minus 3/4, that is going to require some effort. That's going to be steps, because why? I need to get a common denominator. So I'm going to have to find equivalent fractions for both 2/3 and 3/4, or -3/4 if you will, okay? And then subtract them, and then simplify them if I need to, and then divide it by the subtraction in blue, right? That's a lot of stuff. So what I'm going to do is I'm going to have a purple thought cloud. If you've seen much of what I do, I have thought clouds for things. So we're going to come out here, except not in orange because I just said purple. So I wrote that in purple. So we're going to come out here and we're going to have a purple thought cloud for this, okay? And I hope if that's not big enough, clouds can reform and reshape, right? So we're going to say 2/3, and I'm going to leave some space minus 3/4 because I need to know my LCD is what? It's 12. My LCD is 12. And how do I get that? I look at the bigger of the two, 4. Does 3 go into 4? No. And I do multiples of 4. 4, 8, 12, 16, 20, 24, until I get to the first one that all the other denominators go into, and all the other ones here are 3. Does 3 go into 8? Nope. 12? Yep. So 12 is my LCD. So what do I multiply by 3 to get 12? 4, right? So I'll put a fraction here, and I put a 4 down here to get to what 3 times 4 is 12. If I put a 4 in the denominator, I got to put a 4 in the numerator, and I'm going to multiply it. Then I'm going to multiply this by something. What do you do here? 3, right? 3 times 4 is 12. So 4 times 3, and this is 3 over 3, because whatever you put in the bottom, you got to put in the top, denominator and numerator, because you want to multiply by 1. Look, the whole reason you did this is to multiply. Don't go, oh, those cross out. No. The whole reason you do that is to multiply. So then you say 2 times 4 is 8 over 12. Minus 3 times 3 is 9 over 12. So then this becomes 8 minus 9 over 12, which is -1 over 12. And if you want to, you can put -1/12. If you want to bring the negative out front, you can leave it there for now. You know it's fixing to be a lot more to deal with. You got -1/12. All right. So what I did, instead of writing this overall orange fraction down several times while I did all the steps for just the numerator, I said, let me just go off to the side in a thought cloud, and I did it in purple here to try to help, okay? Did it in a different color, okay? If you don't see colors, I'm sorry, but I'm trying to show this here. We can give it some kind of effect here, all right? So I went off to the side, and I figured out what that numerator was, just the top. I did the steps to just the top. And that's why I put it in a thought cloud, because I'm not done with my problem. If I don't put it in a thought cloud, I get to -1/12. I go, oh, I'm done. No, you're not done. All you did was find the numerator. Now we got to go back and find the denominator. So I'm going to come down here and have me a little thought cloud in blue. And some of you are going, but it still may require steps. So negative 5 halves minus 1 half. This already has a common denominator. I can go straight to negative 5 minus 1 over 2. Right? Just put the numerators together over 2. It already has an LCD of 2. So this one's much simpler than the purple one. Equals negative 6 over 2. But wait a minute. That's just what? Negative 3, isn't it? And then I'm going to come back over here and put that in my denominator. I'm going to put that in my denominator. So now I have negative 1/12 divided by negative 3. I got a fraction divided by a whole number. But wait a minute. If I got a fraction divided by something, I got to multiply by what? The reciprocal. And if the bottom of the denominator is not a fraction, I've got to make it a fraction, right? So what am I going to do? I'm going to put this over 1. So that way I can come back to my orange here. I can go, okay, m equals, and it's going to equal what? It's going to equal the numerator, negative 1/12, times, if you want to put parentheses, a dot, I could do parentheses or I could do a dot. So I'm going to just do a dot, times, and my fraction here is negative 3's down here now, and then it's 1 over negative 3. And if you want to put the negative out front, actually, let me do that, okay? Let me say this is 1 over, and then negative 3 here, right? So I multiply by the reciprocal. Keep, change, flip, right? I kept the top, changed the division of times, and flipped the bottom, or the denominator, okay? So here, when that happens, what is your slope? Your slope is going to be negative times negative is positive, so I'm not going to worry about that. It's positive. 1 times 1 is 1, over 12 times 3 is 36. So there's your slope, 1 over 36. And this line does what? Rises because it's positive. And just barely so. 136 is not very much, right? But it still rises very slowly. All right, so I hope that this video helps you out with slope. Always, 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 when you're doing something like this that has a formula with it, write the formula down every time you work a problem until you're sick of it. Because then when it comes time on the test to take it, you're going to know it. All right? Good luck.